So, good morning, everyone, and welcome to this special lecture. In this lecture, we are hoping to possibly end this topic on standing waves. What we have been dealing, we have started with standing waves, and we had seen when are standing waves produced. When are standing waves produced? Huh?
When two propagating waves with same amplitude, same direction,
Same direction. Wow,
sorry,
well
opposite
done.
in direction along the same straight line, superimpose
Then we have what we call
stationary waves.
as stationary waves. And we had seen these two waves propagating with angle phi taken as 0, and we had seen that this sort of a thing we will get, and this will be known as equation of a wave. Remember, this is not the only equation of a wave that is possible, stationary wave. Depending on which two waves are interfering or superposing, not interfering, uh, depending on which two waves are superposing, there could be different types of equations. Yes or no, no or yes.
Yes, sir.
Hmm. So what I wrote was only one equation of the possible equations that are there. This equation had a cos term and a sine term. What are the other possible equations? And obviously these equations will come from trigonometry, sine A plus sine B or sine A minus sine B or whatever. So what are the other options that are possible? This is just one equation I have written. Do we understand what I'm saying? What is going about? I saying by what? This is just one equation of the standing wave I've written. There could be other equations depending on the constituent waves. Yes? Huh? What are the other equations possible? I don't know, sir. How do I know, sir?
The 2a sine kx cos omega t,
Okay.
2a cos kx cos omega t,
Yes.
2a sine kx sin omega t.
So depending on which two waves are interfering, you can find out the constituent waves. Yes or no?
Yes, sir.
From this equation, 2a cos kx sin omega t, 2 cos a sin b. From that formula, you can find out the constituent waves. Yes or no?
Yes, sir.
So you can convert product into addition, and from there you will get the value of the constituent. From there you will get the wave equation of the constituent waves. We have just taken one example. It's not possible for us to write all the equation because this is simple trigonometry. Do we understand this? So we had seen that this is the equation of a wave because it follows this differential equation of the wave. So this is definitely equation of wave, but it is not in the form of y is a function of x and t, because y is not a function of x and t coming together, and therefore this is not a traveling wave, but this is a stationary wave. Now this wave represents the equation of all particles at all times along the wave, and you can see all these particles are executing shm. Yes or no?
Yes, sir.
These all particles, they execute shm. The shm is of same omega, but they have different amplitudes. Do we see? Because the amplitude of this SHM depends on where the particle is situated. Do we understand this?
Yes, sir.
At some points, the amplitude of this SHM is simply zero. We call those points as nodes, and the distance between two consecutive nodes is lambda by 2. We have seen that. Yes or no?
Yes, sir.
Between any two consecutive antinodes where the displacement or the amplitude is maximum, 2a, 2 times the amplitude of the constituent waves, those points are known as antinodes, and the distance between two antinodes is also lambda by 2. You seen that, right or no?
Yes, sir.
Similarly, we have also seen that the distance between a node and an antinode would be lambda by 4. Yes or no? No or yes?
Yes, sir.
Hmm. Then we had seen that this node, and that is the most important aspect that we are going to see and take our discussion further. This node, any two nodes, divide it into loops or sections. Do you see these loops or sections? Yes or no?
Yes, sir.
We have, if I color it, we have this pink loop, and then we have this blue loop. Do you see these two loops? This is the pink loop, and this is the blue loop. Do you see these two loops? Yes or no?
Yes, sir.
So basically, these loops have been divided because of the two nodes that you see. Yes or no? Now, normally these stationary waves are represented in this fashion. They are represented like this. What it actually means is, this is basically snapshot of the wave. This is basically the snapshot of the wave taken at two instants. This is the snapshot of the wave taken at two instants. This is the snapshot of the wave taken at two instants. This is the snapshot of the wave taken at two instants. What are those two instants? The first instant, the wave is like this. This part. This is the first instant where the snapshot of the wave is taken, where particles on the left of the node are at their maximum positive positions. Do we understand this?
Yes, sir.
But the particles on the left, on the right of the node, the blue side particles, they are on their maximum displacement, but on the negative side. So that is the first snapshot that has been taken. Do we understand this?
Yes, sir.
Then there is a second snapshot that was taken, that is taken. And this blue thing is the second snapshot that is taken. What is the difference between this blue snapshot and this pink snapshot? This blue snapshot is taken when the particles on the pink loop have gone to their maximum displacements on the negative side, and the blue one have gone on to the positive displacement on the positive side. Do we understand this?
Yes, sir.
Now from this we can understand one thing very clearly, that all the particles on the blue side are in the same phase. Do we understand this? All these pink particles are in the same phase. Do we understand this?
Yes, sir.
That means they are all moving together. They are all moving together in what sense? They will all reach their maximum positions together. They will all reach their minimum mean positions together, and they will reach their left side or downside maximums together. So they move like this, dung 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 dung, all together. But their amplitudes are different, and therefore you have the wave pattern like this. Do we understand this?
Yes, sir.
But when these particles are moving on this side, the other particles are moving on the other side. That means all these particles on the blue are also in the same phase. Do we understand this?
Yes, sir.
All the particles on the blue side are also on the same phase. But if I compare any particle on the blue phase with any particle on the pink phase, they will be 180-degree out of phase. Do we understand this? They are 180-degree out of phase of each other. Do we understand this?
Yes, sir.
So even though they are 180-degree out of phase of each other, all these particles, they will pass their mean positions together. Yes or no?
Yes, sir.
They will pass their mean position twice in one cycle together. So twice in one cycle, you will have this wave coming like a straight line. This wave will become a straight line twice in one time period. Do we understand this, or this has gone above our head saying bye bye? So particle on one side of the node, they are all in same phase but moving with different amplitudes. Particle on the other side of the node are also in the same phase but moving with different amplitudes. Particles on either side of the node, If I compare one particle from the pink zone and if I compare other particle from the blue zone, they will be 180-degree out of phase. Do we understand this?
Yes, sir.
Everyone understands this?
Yes,
Yes
sir.
or no, no or yes? Everyone understands this?
Yes,
Shall
sir.
I move ahead? Everyone has written this down. Everyone has understood this.
Yes, sir.
This is the most important aspect of this wave, that particles on one segment are in the same phase, particles on the other segment are in the same phase, but any two consecutive segments, they are 180-degree out of phase. Do we understand this?
Yes, sir.
Now, remember, these particles which are at nodes, the particles which are at nodes are permanently at rest. Do we understand this? They don't move anywhere. So no energy can be transmitted across them. That means energy of one region is confined in that region, and therefore this wave is known as water. Therefore this wave is known as, what is the name of this wave?
Standing wave.
Because energy cannot be transferred. It remains between two nodes. Hey, Bhagwan. We are studying standing waves and we don't know what is standing. The energy cannot be transferred. It remains between two nodes. It is confined between the nodes. It cannot get transferred. Therefore, this wave is known as standing wave. But this energy keeps on changing from potential to kinetic to potential to kinetic, because it is simple. It is a it is a simple harmonic motion. Do we understand this?
Yes, sir.
But the only difference is this is not simple harmonic motion of one particle, but this is simple harmonic motion of many particles. Therefore, according to that simple harmonic motion, the energy keeps on changing from potential to kinetic, from kinetic to potential when they are passing through their mean positions. The entire energy is kinetic energy. Do we understand this?
Yes, sir.
When they are passing their mean position, the entire energy is kinetic energy. When they are at their extreme positions, the entire energy is potential energy. The first diagram shows the particle at their extreme position. The second diagram shows the particle at their mean position. And when the particles are passing their mean position, the entire energy is kinetic in nature. When the particles are on their extreme position, the entire energy is potential energy. In between them, it is a mixture of kinetic and potential energy. Remember, it is the case of a simple harmonic motion. Do we understand this?
Yes, sir.
The total energy in a segment will always remain constant. We understand this one as well. Because it is a simple harmonic motion, bacha, nothing else, nothing less, nothing more. Do we understand this? Or this is gone above or saying bye bye. Bye bye, sir. I'm going bye bye, bye bye, bye bye. बहुत हो गया, sir. Bye bye, bye bye, bye bye. Anyone understands this?
Yes, sir.
You will get 2 minutes to note this down. You don't have to note down the entire Ramayana. No one is asking you the entire Ramayana. The only thing we are concerned is who was Ram Bhagwan and who is Sita Ji. Here Ram Bhagwan is the extreme position and Sita Ji is the mean position. That is what you must understand. Okay? 2 minutes, note it down. Okay, whatever we have understood about stationary waves, let us now note them down as important points and we will try to sum up everything in these important points. If you understand stationary waves like this, well, we are done with our thing. What is the first thing that you must understand about a stationary wave? A stationary wave is produced in a bonded medium. The medium must be bonded. If it is not a bonded medium, stationary waves cannot be produced. Now, this bonded medium, first just listen to me, then I'll give the time to write. If you are able to understand it, you can write while I am explaining it as well. Stationary waves are produced in a bonded medium. The medium has to be bonded. It could be free, it could be rigid, but it has to be a bonded medium. It cannot be created in an open medium. The medium has to be bounded. Do we understand this? Yes. Important, more important than writing is understanding what we are writing. Now remember, this disturbance that is produced is confined. So it has to be happening in a bonded medium. The disturbance is confined to a particular region. So stationary waves are confined. They are not free to move everywhere. They're confined. Do we understand this? Stationary waves are confined. Stationary waves are confined to a particular region. I hope everyone is noting it down. Now, the next point is there is no forward motion of this disturbance from one particle to the other or the adjoining particle beyond this particular region. There is no motion, forward motion of the disturbance. The disturbance does not move forward. I hope you understand this. Now remember, the total energy associated with a stationary wave is twice the energy of each of the incident and the reflected wave. But there is no flow or no transfer of energy. Do we understand this? There is no transfer of energy between the nodes. The energy does not get transferred. You must understand this. Energy does not get transferred. Now, in stationary waves, you must understand that these nodes and antinodes are formed alternatively. Do we understand? After one node, there cannot be another node. There has to be an antinode. Nodes are the points which are always at rest, having maximum strain. Remember this. Nodes are the point. They are not moving, so they have maximum strain. Whereas antinodes are the point which have maximum amplitude but minimum strain. I hope everyone is able to understand what we are writing and everyone is writing it together.
Yes, sir.
Okay, I'll keep on moving ahead while you are noting down the points. I will keep on moving ahead and add more points. All particles, they are in simple harmonic motion. Remember that all particles are in simple harmonic motion and all the particles are oscillating, vibrating simple harmonically with the same time period. You can also add same time period, that is capital T, omega and F. All these things are same for all the particles, but their amplitudes are not same. So you must remember this, understand this, that the frequency, angular frequency is same, but the amplitudes are not same. Amplitudes keep on increasing from 0 to maximum, from node to antinode. Everyone understands this? Yes or no? No, yes. I hope all the points are becoming clear. Yes or no?
Yes, sir.
The distance between any two consecutive nodes or between any two consecutive antinodes is lambda by 2. Do we understand this? Yes or no? No, yes. The distance between any node and antinode, between any node and an antinode has to be lambda by 4. Do we understand this? Is it going above our heads? Huh? Are we able to understand this? Everyone able to follow what I'm saying? Then we have seen that the medium splits into different segments. Have you seen that segment between two nodes? There is a segment. Each segment is vibrating up and down as a whole. Do we understand this? Do we understand this, or this has gone above our head saying bye bye, sir, bye bye, we are going, bye bye? Are we able to understand this? Yes or no? I'm not seeing any response. I'm getting worried.
We understood.
All particles in one particular segment vibrate in the same phase. In the blue segment, in the pink segment, all in the same phase. But they differ from other segment by a phase angle of pi by 2 of pi. Yes or no?
Yes, sir.
Okay. All particles pass their mean position simultaneously. All particles, any segment, they pass their mean position simultaneously, my dear friends. I hope points are getting clearer. Points are getting clearer. Yes or no? The wavelength and the time period of the stationary wave is same as that of the component waves. Very important point. Wavelength, time period of the stationary wave is same as that of the component wave. Now, their amplitudes are different and therefore their maximum velocities are also different. The particle at node will have zero velocity, while the particle at antinode will have maximum velocity. Do we understand this? V max is A into omega. If A is more, omega is same. They will have more velocity. Do we understand this?
Yes, sir.
Now, this same scene can be seen in longitudinal waves. In case of a string, you can see them going together and going down together, going up together, going down together. But in longitudinal wave, you cannot see that motion. For sound waves, for example, so what happens is compression and rarefaction do not travel forward, but they appear and disappear. So you will see compression, then you will see rarefaction, then you will see compression. I hope Everything is making sense. Most important point, there is no energy transfer. What is the only job of a wave? What does a wave do? Huh? Transfers what? Stuff. This is my stuff. You are a wave, carry it. What is the main function of a wave? What is a wave? Huh?
Transfers energy.
It transfers energy, but this stationary wave does not transfer energy. It stores energy, yes, in one region, yes, but the energy cannot be transferred. Do we understand it? Yes or no? No, yes. Last point, one of the important points coming up, and then I'll give you time. And the last point, if the amplitudes are of the component waves are not equal, the amplitude of the component waves are not equal, then the resultant amplitude at node will not be zero, and therefore some energy will pass from node to the next segment. So node to node energy will only remain constrained if we have the equal amplitudes of the two waves. I hope this point is clear to everyone in the class. Yes or no? No or yes? Everyone has understood these points, or they have gone above our head saying bye bye? Bye bye, I am point and I am going bye bye. Do we understand this, or this has gone above our heads, bacha? Have you noted it down? Or still noting down?
We
Huh?
need time, sir.
You need time, sir, so I'll give you 5 minutes, sir. Please let me know once you are done. Can you do that? If you have doubts in any aspect, please feel free to let me know. I'll give you 2 minutes to note down each and every point, go through each and every point. This is the most important aspect of a standing way. I'll give you 2 minutes. Then let us move ahead and see the differences between the two types of waves that we have studied. Progressive waves, traveling waves, and khadi hui wave, standing wave. Progressive wave, first listen to me. If you have any doubt, then you write. Progressive wave, why they are progressive? Because they travel. Why they are stationary? Because they do not travel, they remain between 2 points, the energy remains confined. What is the purpose of this? To transmit energy. What is the purpose of this? This does not transmit energy, this just stores energy between 2 points. Now, here the phase of vibration varies continuously from one particle to the other particle. When particles are in a progressive wave, their phase are from one particle to another particle, the phase is constantly varying. But here, the phase of all particles between two nodes is same. Between adjacent nodes, it differs by an angle of pi. So either it is 0 or it is pi. Do we understand this? No particle is permanently at rest. Nodes are permanently at rest. These vibrate with the same amplitude. These vibrate with different amplitudes. Amplitude of node is 0, amplitude of antinode is maximum. No particle attain, all the particles do not attain their maximum position simultaneously. Here all particles attain maximum displacement simultaneously. Between two nodes, they will be on the positive side. Between other two nodes, they will be on the negative side. So this basically encompasses everything that we have learned in progressive and stationary waves. I'll give you 2 minutes to note this down. Anyone has any doubts on this?
No, sir.
2 minutes to note it down. Welcome back after writing this, and I will now give you a question. I don't think we have sufficient time to solve this question, so I will give it as a homework that you solve. I'll give you 2 questions as homework, so note down those 2 questions, solve them, and bring them up. So we will discuss them in the next class. This is the first question that I'm going to give you. All of these questions are based on the standing wave, and this is the first one for homework so that you can do it at home. This is the first one. Two waves traveling in opposite directions produce a standing wave. The individual wave functions are given. You have to find out the equation of the standing wave. Basically, if you get the equation of the standing wave, you will get everything. Yes or no? So you just have to find out the equation of the standing wave here. That is the first question that you will have to solve. The next question will be the opposite of this. What do you mean by opposite of this question? What do you mean by opposite of this question? Tell me.
Means
Means,
standing wave is given, individual waves to be found.
yeah, standing wave is given and you have to find out the individual wave. Remember, this is not a question of physics anymore. This is a simple, pure question of mathematics. You just have to convert sum of trigonometric functions into product and product of trigonometric function into sum. So these are the 2 questions that we would be discussing in the next class. I'm giving you as homework so that you can go back home, do them on your own, and you can come back. Remember, I don't need the answer. I mean, if you just give me the equation, in the equation we can just put the values. The only thing you have to understand is how do you find the position of nodes and antinodes. It's very simple. To find the position of node, you put displacement as 0, and to find the position of antinodes, you put the displacement as 2a. You will get the position of nodes and antinodes. Do we understand this? So I'll give you these 2 questions as homework, and when we come in the next class we will be discussing these 2 questions. So note down these questions. If you have any doubts, you can come up and ask me any times. I'll take care. I'll dismiss this class here. Bye bye everyone.